to the Modern Networking lecture series. This is lecture number 2. Today in this lecture we will study about some standards, Ethernet, Wi-Fi, etc. So today we will see the key network transmission technologies, that is Ethernet, Wi-Fi and 4G, 5G cellular networks. So generally for connecting the networks, these are the one which are used. So each of the above technologies have evolved to support very high data rates. So we'll see how the Ethernet evolved through the years, and then these data rates support the many multimedia applications required by enterprises and consumers. At the same time, they place great demands on network switching equipments and network management facilities. So Ethernet started with small data rate and it went up as the applications required. Then we had the Wi-Fi techniques, and then with the cellular networks we started with 1G, 2G. We'll see the evolution of this also. So first we start with the Ethernet. Now this Ethernet actually is the predominant wired network technology used in homes, offices, data centers, enterprises and wide area networks. So this Ethernet, it evolved to support data rate up to 100 gigabits per second. This is the rate. And previously the distance of communication was few meters, then it extended to tens of kilometers. Now this has become an essential for supporting PCs, workstations, servers and massive data storage devices in or small to large organizations. Now some of the basic applications of Ethernet. Ethernet in the home. Now with respect to home, as we can see, it has been used in home to create a local network of computers with access to internet through broadband modem or router. Okay, so we can access internet using this particular Ethernet techniques. Two recent extensions of Ethernet technology have enhanced and broadened the use of Ethernet in home. One is the power line carrier, PLC, and the second is power over Ethernet. Now both are complementary of each other. So in the first case, power line carrier, so in that case what is done is that these power line modems, they take the advantage of existing power lines. So we already have the power lines which are supplying power to homes and offices, so we can use those power lines to transmit the Ethernet packets, because the frequency, actually the transmission frequency of the AC which we are getting at our home is 50 to 60 Hertz, and we can use the same line to just transmit the Ethernet packets, okay, at some different frequencies. So two communications can go on. So this was regarding the PLC, power line carrier. Then we have power over Ethernet. Now this is of course complementary as compared to this one. Now in this case, if we already have the Ethernet data cables, okay, which are carrying this packets, Ethernet packets, then the same they can be used for distributing powers to the devices on the network. Okay, so it makes the simplification, okay, the wiring becomes much simple. Okay, so this is regarding the home. Now in case of Ethernet in offices, so Ethernet has been a dominant network technology for wired local area networks in the office environment, okay, because they provide a very high speed. Okay. Now with the coming up of the Wi-Fi technology, of course wired Ethernet also used with respect to the wireless Wi-Fi. Of course wireless Wi-Fi, it has a advantage as compared to this wired Ethernet, that we don't need to connect and reconnect the devices. Okay. Now even with the advent of Wi-Fi, still Ethernet is used. So much of the traffic in the typical office network is of course through Wi-Fi, due to many mobile devices. Now people are using mobile devices, okay, laptops, smartphones, etc. So for that purpose Wi-Fi is more suitable. But still Ethernet, it retains its popularity because it can support many devices at high speeds. Okay, so Ethernet, it can support large number of devices, providing a very large speed, and there is no problem of interference, and of course it also provides security advantage, okay, with respect to eavesdropping. Okay, the most common architecture in the offices is a combination of both Ethernet as well as Wi-Fi. Then Ethernet in the enterprise. So this is the network structure you can see. So we have internet is connected to this. This is the. We also, along with this Ethernet, we also have somewhere where we can use the wireless connectivities. As you can see here, Wi-Fi access points are there. So these mobile devices, they are connected to the routers, the edge routers, through wireless networks. And here we have the Ethernet switch connecting to other networking devices. So Ethernet in the enterprise, you can see a tremendous advantage of the Ethernet is that it is possible to scale the network. We can scale it, means we can just add more and more components to the already network we have. Okay, so it is in terms of distance and data rate both. Okay, and with the same Ethernet protocol and associated quality of service and security standards, so we can provide the required quality of service using the same protocol and same security standards. That is advantage. Now an enterprise can easily extend an Ethernet among a number of buildings on the same campus, even some distance apart, with links ranging from 10 Mbps to 100 Gbps. So this is the speed we are getting, okay, with this Ethernet. Okay, there is a very tremendous speed, 100 Gbps. But because of the hardware and communication software conform to the same standard, it is easy to mix different speeds and different vendor equipment. So even if we have devices which are manufactured by different vendors, still we can connect them. Okay, and even if the devices, they may have different speeds of operation, still we can connect them using the Ethernet technology. Then the same protocol, of course, in this case the same protocol is used for intensive high-speed interconnections of data servers in the single room, then workstations and servers distributed through the building, and links to Ethernet networks in other buildings up to 100 km away. Okay, so you can get the same thing with respect to Ethernet. Another important application of Ethernet is in the data center. So this Ethernet has also become a dominant in the data centers, because in that we require very high data rates, and we have to handle a massive volume of data between the servers and the storage units. So with the data centers, because they require very high volume even for short distances, so we have these techniques at InfiniBand and fiber channels, because the fiber channels, they support a very high data rate. Now with Ethernet, which is scaling up to 100 Gbps, and of course 400 is on the horizon, we need a unified protocol, okay, which can approach through the enterprise. Okay, so this was required. Okay, and Ethernet is also suitable for that purpose. Now two features of new Ethernet approach were noteworthy. The one was high-speed Ethernet fiber links and switches, which provided the needed network infrastructures. So the required networking infrastructure was, of course, provided by the high-speed Ethernet fiber links, and another was the backplane Ethernet, which was of course running through the copper jumper cables and could provide about 100 Gbps for very short distances. Now this particular technique is of course ideal for blade servers. So this was regarding the data centers. Then we have Ethernet for wide area networking. Now this Ethernet, it was of course not very significant factor before in case of wide area networking, because it was covering a very large area. Okay. Then with more and more telecommunication network providers which were switching to Ethernet, okay, from the various other alternatives, so this Ethernet was also then supported, was also used in this wide area networking. Now Ethernet has an advantage that it seamlessly fits into the enterprise network, for which provides wide area access. This is one of the advantages. Another advantage is it provides much more flexibility in terms of data rate capacity that is used as compared to other wide area alternatives. Then next we come to the Ethernet standards. So we have this IEEE 802 LAN Standards Committee, and this 802.3 group, it is responsible for issuing the standards for LAN, okay, and of course we refer to them Ethernet. This 802.3 group, it is responsible for making standards, okay, for LANs. Now some of the common standards we have, these are some of the common standards, okay, 1 Gbps, 10 Gbps, 100, 400. Of course we also had 10 Mbps and so on, but we'll discuss from 1 Gbps. Now this was the 1 Gbps, we come to 1 Gbps. The initial standard of course was 10 Mbps for many years, but because of the growing traffic needs more and more applications, okay, clouds applications, then data servers, then data centers, they require very high data rates, okay? And you can see these are some of the responsible key drivers, we can say, for this 1 Gbps speed. So the first is the centralized server farms, okay? So in many multimedia applications, there is a need for the client to be able to draw huge amount of data from multiple centralized servers called as server farms. So server farms, of course, in many multimedia, of course, in many multimedia applications, the client system, it needs to get large amount of data, okay, and not only from one single server but multiple servers and centralized servers. So for that purpose, we need to enhance the performance of the servers, okay, and if we have fast servers which are serving but the network then becomes the bottleneck, okay, because if the data is coming from multiple servers, okay, and if the networking infrastructure is not supporting that large amount of data, then it can create a bottleneck, okay. So we can use this Ethernet 1 Gbps to support that. Then power work groups. So this group, it consists of a small number of cooperating users, but although the group is small, but they exchange massive amount of files across the network, okay. So they are coordinating, they are cooperating amongst themselves. So for that purpose we need a fast networking, okay, and then high speed local backbone. Now as the processing demand grows, enterprise, they develop an architecture for multiple LANs which are interconnected with high speed backbone network. So even for high speed backbone network where we connect multiple LANs, we can use this particular, this high speed is required, okay. So these are the driving forces. Then after this we come to the next standard, that is 10 Gbps Ethernet, okay. Now with respect to, as we know, more and more data rates were added, okay, and so the main driving force for 10 Gbps was the increase in the intranet, okay, which intranet means local interconnected networks, and also the internet traffic. The internet traffic grew by years, and these are some of the factors which contributed to the explosive growth in both internet and intranet. So the first one was an increase in the number of network connections. More and more networks were added, okay. An increase in connection speed of the end stations, more fast devices they were added, okay, and an increase in deployment of bandwidth intensive applications is high quality videos. So this high quality videos, they require a very large bandwidth, okay, and increasing web hosting and application hosting traffic. So these were the driving forces, okay. So with the increasing demand for the bandwidth, this 10 Gbps began to be deployed throughout the entire network to include the server farms, backbone, campus-wide connectivity. Then next we have is 100 Gbps Ethernet, okay. Now in this was actually in order to support the internet exchanges such as high performance computing and video on demand, more higher data rates were required. So this we require the standard 100 Gbps, and of course these are some of the main drivers for the 100 Gbps Ethernet. The first one was a data center, or we can say internet media providers, okay. So this was to support the growth of internet multimedia connections and web applications. Content providers, they were expanding, okay. Then we have metro, video or service providers. So video on demand has been the driving force for this new generation 10 Gbps. Okay, so this particular 100 Gbps, okay, 10 Gbps not enough for that, so we require more data rates. Okay, and then the enterprise LAN. So with the continuing growth of the convergence, we will see what is unified communication shortly maybe in the next video. So this convergence of voice, video, data into a unified communication, it was also it required a network switch demands, okay, driving up the network switch demands. Then we had internet exchanges or ISP core routing. Okay, so with massive amount of traffic flowing through these nodes, high speed was of course required. Okay. Then finally we come to this 400 Gbps. Okay, so of course the growth in demand never stops. So therefore IEEE 802.3 is currently exploring how to produce this 400 Gbps Ethernet standard, and maybe in the future we may also have this 1 terabytes per second. So this was regarding the Ethernet standard. So next we come to the wireless fidelity. This Wi-Fi we call it as Wi-Fi. Now with Ethernet IEEE 802.3 becoming the dominant technology for wired LANs. So Wi-Fi is IEEE 802.11. So this was .3 for Ethernet, and this is .11 has become a dominant technology for wireless LANs. Okay. Now wireless Wi-Fi is of course a predominant wireless internet access technology which is used in homes, offices, public spaces. Okay, so because in case of Ethernet, if we consider, we need to have wiring, okay, and the host is just tied up with that particular network. But in case of Wi-Fi, the host is not tied up at a particular place, and of course wiring is also not required. Okay, so this one is another option, okay, a more better option as compared to Ethernet. Okay, so these are some of the common applications of the Wi-Fi. That is, you can see Wi-Fi in the home. Then we have public Wi-Fi. Okay, and then we have enterprise Wi-Fi. So in case of home, you can see using a simple router. Okay, this Wi-Fi could be accessed. Okay, and of course we have varieties of devices, just mobile phones, laptops, okay, PDAs, personal digital assistants. They can be easily connected, hassle-free connection can be done. Okay, and of course Wi-Fi, they are supporting large data rates, so this Wi-Fi can be shared. Okay, then we also have public Wi-Fi. Okay, so now public Wi-Fi, this Wi-Fi service is available at various public places like railway stations and hospitals and many other public places. People can access the internet, okay, using the public Wi-Fi. Okay, of course security becomes an issue. Then next we also have for enterprise. Okay, this enterprise Wi-Fi. Okay, now of course it is the benefit is of Wi-Fi is very clearly seen in case of enterprises. So this Wi-Fi connection has been offered by many organizations of all sizes, including public and private sector. Okay, now this is of course increasing. Now the two trends which have driven the transition to Wi-Fi centered enterprises. The first is the demand has increased with more and more employees because they are preferring using laptops, tablets, smartphones to connect to the enterprise network rather than the desktop computer. Then with the arrival of gigabit Ethernet, especially IEEE 802.AC standard, it allows the enterprise network to support high-speed connections to many mobile devices simultaneously. Okay, so there are of course many advantages of this Wi-Fi. Okay, now regarding the Wi-Fi standards, so essential to the success of Wi-Fi is the interoperability, okay, which is guaranteed by these two organizations. This is IEEE 802.11 Wireless LAN Committee. It develops the protocol and signaling standards for Wi-Fi, and we have Wi-Fi Alliance. It creates test suites to certify interoperability for commercial products that conform to various IEEE 802.11 standards. Now these are the various data rates. Okay, that is we started from 802.112 megabits, and then this continues for 554 Mbps, and this is up to 2014 3.2 Gbps. So we will continue with this 4G, 5G cellular networks in the next lecture. So that's all for this particular session. Thanks for watching.